Alright, this is Semester A, Lesson 1.10, which is our Unit 1 test, and we're working on Part 2, which we also call the Teacher Graded Assignment. So right off the bat, I want you to understand that if you give me the correct answers without showing your work, what I'm looking for is your work more than anything else. So just giving me the answers without solving the inequality, showing your answer on a number line, and stating your answer in interval notation will not give you enough points to pass. Alright, so let's look at what we've been given. Alright, we have 6x squared plus x is greater than or equal to 1. Now I want you to notice that we have an inequality, so we've got to be careful about just doing any kind of operation. We cannot multiply or divide through by a negative because this will change direction, this inequality symbol. So the first thing that we need to do is we need to move everything over to one side. So I'm going to rewrite this so you can see it maybe a little bit bigger. 6x squared plus x is greater than 1. So I'm going to subtract 1 from the right, and I'm going to subtract 1 from the left. Now on the left, these terms are all different, so we're just going to order them from the highest power. 6x squared plus x minus 1 is greater than 1 minus 1 is 0. Okay, so we're going to be working with this just like we would in equality. We're going to factor the left-hand side, and I'm going to use a factoring calculator. So you can see with the Math Papa factoring calculator that I have saved for you in the I Can, we're going to put in that 6x squared plus x is greater than, minus 1. And then we'll ask Math Papa to calculate it for us. That'll save you a little bit of time, and it'll show you the steps so you can double check your work. And we factor it into 3x minus 1 times 2x plus 1. Alright, so we factored it into 3x minus 1 times 2x plus 1. And that's greater than 0. Alright, so I'm going to set each of these factors equal to 0 and find my points of interest. So let me draw a number line, sketch those on the number line. Alright, when I set 3x minus 1 equal to 0, add 1 to both sides, and I'll get 3x is equal to 1, divide by 3, and x equals 1/3. So I'm going to put 0 here. I'm going to stretch this out so we can see it better. And this will be 1. Alright, so 1/3 would be about right here. And because it's not equal to, it's just greater than. Now it looks like it's equal to. Let me circle it. We're going to circle that. That's going to be a point of interest. And then I'm going to go to the next one. 2x plus 1 equals 0. Subtract 1 from both sides, and I get 2x is equal to negative 1, divide by 2, and then x is equal to negative 1/2. Right, now I need to go over a little bit more to the left, and negative 1/2 is about right here. So we're going to circle that. Again, it's open, we don't have an equal sign. And then I'm going to divide this. I'm just going to draw dotted lines. Divide this number line into 3 sections. So there's a section over here. I'll label that section number 1. There's a section, a dotted line here at our second point of interest. So there's an area here, I'll call it area 2, and then over here on that side is area 3. I'll circle those so you don't get confused with the number line. All right, now I'm going to find any point in these three areas and plug it into my inequality to see if I have a true statement. So I'm going to start with the easiest one, 0. 0 is right here. Plug it in to this and we'll get 0 times 6 is 0, plus 0, because 0 squared is 0. 0 times 6 is 0, plus 0 is 0. Is 0 greater than -1? Yes. So everything, any point that you choose in this area will make that statement true. So now I'm going to move over here to the left. Make sure you can see it. Anything that's less than -1/2, I'll choose -1. So I'll put -1 and square it. -1 squared is +1 times 6 is +6. Plus -1, we're going to substitute that in everywhere there's an x. We'll get 5 is 5 greater than, is 5 greater than 1. Let's look at that for a minute. Let me go back and look at this. It's going too fast. So let me move up and rewrite this. We're looking at 6x squared, go back to the original, plus x greater than 1. So we're going to put that 0 in here for x. 0 squared is 0, 0 times 6 is 0, plus 0 is 0 greater than 1. 0 is not greater than 1, so this is no. Go slowly and carefully. Now I want to choose something that's greater than 1/3. Now this is not 0.3, that's why I wanted to be very careful. Maybe I should label them A, B, and C. Put that down here. Okay, so 1/3 is right here. I'm going to pick 1, the number 1. Oh, number 1's over here. I already see it, that's 2/3. 1 right here. So this is in this area. So I'll pick 1. Substitute it back in here. 1 squared is 1 times 6 is 6 plus 1 is 7. Is 7 greater than 1? Yes. Or to have one more area to check, and it's this area over here. So I'm going to pick a number that's any number you can pick. I'm going to pick -1. That's easy for me. So we'll go back here. -1 squared is 1. So that's 1 times 6 plus -1. Is that greater than 1? This is 6 minus 1 is 5. So that is true. So I'll say yes. So this area is not part of our solution. The area to the left of -1/2, so from -infinity to -1/2, but not including -1/2. Use the union symbol, not the capital U. Okay, and then we're going to unite that with this section here from 1/3 to positive infinity. Okay, so this is our answer on the number line where we've checked each value in each of those three sections by factoring this, putting everything on the left, factoring this, finding points of interest, and then checking those numbers out. All right, so this is our answer, and those are the points on the graph. Let's make sure that we show your answer on the number line. Check, so make sure that we highlight. Let me go ahead and highlight because I've got a lot going on there so that you can make it really clear that our answers are here and here. All right, we're going to go on to question number 2. We're going to graph the function f of x equals 3x cubed minus 6x squared minus 3x plus 6. Trying to see. Okay. All right, name any x-intercepts and y-intercepts in the graph of the function. All right, so we're going to have x and y intercepts. So we're going to have a coordinate plane, an x and a y axis. Let me go ahead and sketch that in there. And if you remember, I have told you that in the I Can, I have an end behavior chart that's very handy for you to have in your notes. So let's start with the end behavior. We're going to look at this function, and the highest power is 3, so it's a trinomial. Okay, so that's an odd degree, and the leading coefficient is positive 3, and it is a positive 3, not a negative. So on my chart, what that's going to look like, my end behavior cheat sheet, as we start at 0 and x goes to negative infinity, the y is going to go up to positive infinity. Okay, and then as x goes to positive infinity in this direction, y is going to go down. So it's going to look something like this. We're just sketching it in. So to help fill that in, we need to find our x-intercepts. So we need to factor 3x cubed minus 6x squared minus 3x plus 6. So I'm not going to move over to the factoring calculator. I think you know how to do that, or you should get familiar with that. Let me go ahead and put that in and write our solution. All right, 3x cubed minus 6x squared minus 3x plus 6. All right, and let the calculator do the work for me. If you need to see every step, it's on there for you, which is what I love about this. So reviewing your factoring certainly doesn't help. I mean, it doesn't hurt, it does help. So it factors into 3 times x minus 2 times x plus 1 times x minus 1. All right, so if we set each of these, there's no x here, so we don't have to consider that. If we set this equal to 0, we'll have x equals 2. If we set this equal to 0, we'll have x equals negative 1. And we set this equal to 0, we'll have x equals positive 1. So let's put those on our x-axis at, let's see, we'll just put 1, 2. And this is an equality, so I'm going to shade that in. And then at negative 1, we also have a place where that graph's going to touch, and then at positive 1. So you have 3 shaded areas here. All right, it also says to find, those are the x-intercepts, and the y-intercept. So to find the y-intercept, you will take this function, we'll take f of x, trying to see where I have room and you can still see, f of x equals 3x cubed. We're going to substitute in, we're going to do f of 0. Let x be 0. So 0 to the third is 0 times 3 is 0. Second term is minus 6x squared. So again, x squared is 0 times 6 is 0. So we're adding it, or we're subtracting or adding another 0. And then minus 3x, of course, that's going to be 0 plus 6. So all we're going to get when we substitute in 0 for x is y is going to equal to 6. So on the y-axis, I'm going to shorten this up a little bit, truncate it. 1, 2, 3, 4, 5, 6. Okay, so now we can sketch this in. It's going to go, let me go ahead and mark this. This is negative 1. It's positive 1 and positive 2. So it's going to go down. And do I have that? That's a negative 6. I was going to say, I was looking at this and going, how's it going to go up? All right, so that's going to go down negative 6. 1, 2, 3, 4, 5, 6, and cross the y-axis here. So it's going to go down, cross, up, and down. So there we go. That's the sketch. All right, on this one, we're asked to graph the function f of x equals x squared minus 3x over 2x squared minus 5x minus 3. So we're going to factor the numerator first. If you look at both terms, both have an x in them, so let's factor out an x. So this is x times x minus 3. Right, and then we're going to factor 2x squared minus 5x minus 3. Use your factoring calculator. So let me put that in real quick and come up with our solution, and it'll come up with all the steps as well so we can double check. So we want the factors of 2x squared minus 5x minus 3. Just make sure that I got that right, and it factors into 2x plus 1 times x minus 3. Now take a minute to look at that and notice that the top, both the numerator and the denominator, have an x minus 3 in them. So that's going to be the x part of our whole in the function. So that cancels out. Whatever we have in the numerator in common with the denominator, that cancels out. That's just 1. So we don't have to write that. But we're going to set that point of interest, x minus 3 equals 0, set it equal to 0, and solve for x. So at x equals 3, we're going to plug that into whatever's left, x over 2x plus 1. So we'll have 3 on the top, and then we'll have 2 times 3 on the bottom, plus 1. So let's keep simplifying. 3 over 2 times 3 is 6, plus 1 is 7. So 3 over 7. So our y coordinate is going to be when x is 3. Let me go ahead and write it over here. When x is 3, y is going to be 3/7. So this is where we'll have a hole in our function. All right, now let's go ahead and factor that. We have the hole here. So let me label that. And then we're going to set this denominator, 2x plus 1, equal to 0. Subtract 1 from both sides, and we'll have 2x is equal to negative 1. Then divide by 2, and we'll get x is equal to negative 1/2. Now we already know at x equal 3, we're going to have a hole right here. So we have an asymptote here and a hole here. So let me sketch that. So you have our x and y coordinates. Okay, and at negative 1/2, so if this is 1, we'll make this be negative 1/2. And we'll draw a dotted line going up and down. So the graph's going to approach but never touch there. So over here, it's going to go up like this. And there's another thing I didn't consider. I need to find that the horizontal asymptote. So when these two are equal, do I have a horizontal asymptote? Let me look at it real quick. I know I have a vertical asymptote here. I know that when x is 0, put a 0 in here for x, y is going to be 0 as well, 0 over 1, which is still 0. So we're going to have it cross right here. It's not going to touch that asymptote, so it's going to go down here. And then it's going to go up at 3, wherever 3 is. Have a hole right there at where is that point? 3 3/7. 3, and let's just say that it's right here. It's going to have a hole. So it's going to go up like this, and we're just sketching, and then leave that open right there. So that's the graph. That's question number 3. Now you'll notice there's a question number 4, and I'm seeing a lot of copying because we didn't really cover this a lot. So mark that off. You don't have to do question number 4, just 1, 2, and 3. We'll cover this again another time in class. All right, so follow those steps to answer your questions for the part 2.